Imagine a sea of shimmering ice and rock that stretches over 175,000 miles, yet remains just about 30 feet thick. That's what we see in Saturn's rings, and within this thin band of particles, there are waves, some rising over 2 miles high. These waves tell a story not just of gravity and motion, but of a cosmic dance between Saturn and its moons that's been playing out for millions of years. As we gaze at Saturn through telescopes and enhanced spacecraft images, the intricate patterns of its rings are more than just celestial eye candy. They are profound puzzles that astronomers are eager to solve. Why do these waves form? How do they shift and change? And what can they teach us about the broader universe? Today, we're peeling back the layers of this mystery and revealing the unseen forces sculpting these grand ringed masterpieces. To understand these enigmatic waves, we first need to step back and look at the foundational principles of Saturn's rings. Think of the rings as a giant cosmic racetrack where trillions of particles speed around Saturn, each with its own orbit. These particles range from tiny grains of dust to large boulders, some as big as a house. They're made mostly of water ice mixed with dust and other chemicals, reflecting sunlight and giving the rings their brilliant shine. As these particles orbit the planet, they sometimes cluster together, clumping under their own mutual gravity, but they can also be stretched apart by Saturn's powerful gravitational pull. This delicate balance between collision and cohesion leads to the formation of waves. Just like ripples in a pond, disturbances in the ring can create wave patterns that travel through the icy particles. These waves are primarily of two types: density waves and bending waves, and they form due to the gravitational influence of Saturn's more than 80 moons. But here's what makes it stranger. These waves are not simply static patterns. They are constantly changing, sometimes even disappearing and reappearing, as if choreographed by an unseen hand. Take the case of shepherd moons, like Prometheus and Pandora, which are nestled close to the F ring. These moons weave intricate patterns in the rings, their gravitational forces acting like cosmic shepherds, corralling the particles into place. When a moon's orbit resonates with a ring particle's orbit, their gravitational interactions create waves that ripple outward through the ring. These resonances are so precise that they act like the tuning of a musical instrument, creating patterns that we can predict and study. The fascinating detail here is how Saturn's moons play a crucial role in shaping these rings, acting almost like an artist with a brush. So when the Cassini spacecraft orbited Saturn between 2004 and 2017, it provided us with a treasure trove of data about these dynamic patterns. One of Cassini's most exciting discoveries was the detection of spiral density waves, spiral-shaped patterns that stretch across thousands of miles of the rings. These waves are generated by the gravitational pull of Saturn's moons, and their appearance and behavior provide clues about the moon's masses and orbits, as well as the density of the ring particles themselves. The cutting-edge discovery rocking scientists' understanding right now is the phenomena known as propeller patterns. These are gaps and waves created by small moonlets embedded within the rings. The gravity of these moonlets disturbs the surrounding ring particles, forming propeller-shaped patterns. These patterns, first observed by Cassini, suggest that Saturn's rings are a kind of moon nursery, where new moons might be forming from the ring material. This insight challenges our conception of how moons in our solar system could form and evolve, hinting at similar processes that might occur around other planets elsewhere in the universe. Why does any of this matter to us here on Earth? These waves in Saturn's rings are not just esoteric celestial happenings. They offer a natural laboratory for studying the physics of disks, which are crucial to our understanding of galaxy formation, planetary system development, and even the origins of dust disks around distant stars. By studying the rings of Saturn, astronomers are essentially studying the processes that created the solar system itself. Processes that might be happening right now around other stars. These rings are a key to unlocking the mysteries of how cosmic systems come into being and evolve. And while we've learned so much, there is still so much we don't know. For instance, we're still trying to understand the exact composition of the rings, as well as their ultimate fate. Are they remnants of a moon that was torn apart by Saturn's gravity, or are they a product of the planet's primordial past? How long have they been there, and how long will they last? These open questions keep scientists probing deeper, using simulations and observations in an attempt to piece together this giant cosmic puzzle. The biggest takeaway from Saturn's rings is the reminder of how interconnected everything in the universe is, governed by fundamental forces that are at once invisible and yet spectacularly visible in the ring's patterns and movements. The next time you look up at Saturn through a telescope, remember the waves and the moons, and the way they dance together in a symphony that has been playing for eons. It's a dance that connects us to the stars and to the galaxies beyond. Thank you for joining us on this journey through Saturn's rings. If you want more deep dives like this, subscribe to Deep Sky Daily.